All right, folks, let's continue with solving equations, solving polynomial equations using the Rational Root Theorem, the Remainder Theorem, the Factor Theorem, plus what we know about factoring. We could even use the Quadratic Formula. In fact, maybe we'll do the Quadratic Formula on the second one that we're solving today. Okay, so we have this polynomial equation, and we're going to go through these 5 steps here. Step 1 says set one side of the equation equal to 0. Well, we have, oh, this is supposed to be a 5x to the third. Sorry about that. 5x to the third. Okay, so here we got a 5x to the third, and we've got a 2x to the third over here. I want my coefficient, I want that to be a positive number. So I'm going to move this stuff over to this side. I'm going to subtract 2x to the third here and subtract 2x to the third here. That's going to cancel here. Then I'm going to add 22x squared here, and I'm going to add 22x squared here. That's going to cancel over here. Then I'm going to add 17x over here and add 17x over here. That's going to cancel over here. Then I'm going to subtract 4 here and subtract 4 here. That's going to cancel over here, leaving me with 0 on this side. That looks like a 6. Leaving me with, let's fix that. Leaving me with 0 on this side. Over here, 5x cubed minus 2x cubed is 3x cubed. X squared plus 22x squared is 23x squared. Negative 4x plus 17x is plus 13x. And negative 3 minus 4, that's minus 7. Okay? All right, so that's step 1. We set one side equal to 0. Now we're going to use the Rational Root Theorem to find all the possible zeros, which we're going to list here, all the possible roots, where our p's are coming from 7 and our q's are coming from 3. Well, this should be a pretty easy one because there aren't many factors of 7 or 3. All right, so 7 only has factors of 1 and 7, and 3 only has factors of 1 and 3. Okay? And so we're going to put all of our p's over all of our q's. Okay, remember, it's this over this, the back over the front. Okay? So 1 over 1 is positive 1, right? 1 divided by 1. So we got 1 over 1, 7 over 1. 1 over 3, 7 over 3. Okay, so 1 over 1 is positive 1, so we're going to do plus, or we're going to put positive 1, and then don't forget, we have to do the negative version of that number, negative 1. 7 over 1 is 7, so we're going to do positive 7 and negative 7. Now we're going to do 1 over 3, so we're going to do positive 1/3 and negative 1/3. Then we're going to do 7 over 3. We're going to do positive 7 over 3 and negative 7 over 3. So this time we only have 8 possible rational roots. This should make it pretty easy. So at most, we're going to do 7 synthetic divisions. Now I want to warn you about something. You can actually find all of your possible rational roots and then do all of the synthetic divisions that are necessary and find that none of them have a remainder of 0. If that happens, it means that none of the roots, if there are any, now this one has at least one root because it's a third power polynomial, so it has at least one root. And I'll talk about that another time. But it's possible that all of the roots are irrational roots. Okay, so here's what we're going to do. We are going to do synthetic division. Step 3, plug all possible roots from step 2, right here, 8 of them, into the expression using synthetic division, looking for a remainder of 0. I always start with the easiest things to do synthetic division with. 1s and negative 1s are easy. Then whole numbers, even though they're big, are still easier than fractions. So we'll do 1, then negative 1, then 7, then negative 7, and then we'll see if we don't get any remainders of 0, then we'll go to the fractions. So we'll start with 1. So you're going to put a 1 in the half box. Then we're going to use 3 and 23, positive 13, and negative 7. Notice that the polynomial did not skip over any powers. And because it didn't skip over any powers, we got third power, second power, first power, constant. We don't have to put any zeros in. All right, now I'm going to draw this line. We're going to do synthetic division. So I'm going to put a 0 here. 3 plus 0 is 3. 3 times 1 is 3. Plus 23 is 26. Times 1 is 26. Plus 13 is 39. Times 1 is 39. Minus 7 is 32. Remainder is not 0. Therefore, 1 is not one of the roots of this polynomial. All right? So now we're going to try, what's the next one? Negative 1. So try negative 1. Put a 0 here. 3 plus 0 is 3. Now, by the way, if you want to pause right now and do all the synthetic divisions here, by all means do so. Or just, why don't you just pause and do synthetic division with negative 1, and then unpause it when you're done, and you can watch me. 3 times negative 1 is negative 3. Plus 23 is 20. 20 times negative 1 is negative 20. Plus 13 is negative 7. Negative 7 times negative 1 is positive 7. Minus 7 is 0. So we have our first rational root. Okay? So we know that 1 is, or not 1, negative 1 is one of the roots of this polynomial right here. So that means, so what would this factor be? What binomial goes with a 0 of negative 1? X plus 1, right? X plus 1, because negative 1 plus 1 equals 0. Therefore, this is a factor and that's a solution. It equals 0. All right, now let's try positive 7. But remember, we're not going to try it on these 4 numbers. We're now going to use 3, 20, and negative 7. We have broken the polynomial down. And so now we can use these numbers instead. By the way, if this is x to the third, what is this going to be? It's going to be x to the second, right? So this is actually 3x squared, positive 20, plus 20x minus 7, right? Now, maybe you can factor this. If you can factor this, because you know how to factor quadratics, right? We spent a whole week on, or a whole day or a couple days on factoring quadratics and then solving quadratic equations. If this is factorable, you don't have to do any more synthetic division. You can just factor this, get the last factors, set them equal to 0, and solve. Okay? But I don't want to do that. That's not fun right now. Right now, we're doing synthetic division. So let's stay with the 3, the 20, and the negative 7. We're going to try positive 7. So I'm going to put 7 in a half box. I'm going to draw a line here. We're only using these 3 numbers. Put a 0 here. 3 plus 0 is 3. 3 times 7 is 21. 21 plus 20 is 41. 41 times 7 is 287. Minus 7 is 280. This remainder is not 0. Therefore, 7 is not one of the roots of that polynomial. Nope. Alrighty. Now let's try negative 7. That's the next one on our list, negative 7. I really hope this is a root, because if it's not, we're going to have to start trying fractions here. I'm not excited about it. I don't mind doing it, but it just takes a little more time and a little more work. I'm going to put a 0 here. 3 plus 0 is 3. 3 times negative 7 is negative 21. Plus 20 is negative 1. Negative 1 times negative 7 is 7. And 7 minus 7 is 0. All right, we got it. We've got our second. We got a remainder of 0. Therefore, negative 7 is a root. It's a 0 of this polynomial. There we go. And that means that the factor of this polynomial is x. This says minus 7, so this is x plus 7, because negative 7 plus 7 equals 0, right? And now what does this become? If this started off as x to the third, then after the first round of division, this became x to the second. If this was x to the second, then what does that make this? X to the first. So this is 3x minus 1. So 3x minus 1, oh, that's a factor. Look at that. We can always, so every time, whenever you get to the very end, whenever you get down to only 2 numbers, that is one of your factors, as long as your remainder is 0. So now this is the third factor. So there are 3 factors in this polynomial, which doesn't surprise me, because it is a third power polynomial. That's step 3. Step 4. Well, now we've just finished step 4. Divide out all factors until the expression is in factored form. And it is. We now have it in factored form. The last thing we're going to do now is we're going to set each one of the factors equal to 0 and solve. So we're going to do 3x minus 1 equals 0, x plus 1 equals 0, and x plus 7 equals 0. Here, subtract 7 from both sides, and we get x equals negative 7, which, by the way, we already knew because, look, negative 7, negative 7. Can you guess what this one's going to be? Yep. Subtract 1, x equals negative 1. Last answer, looks like this is going to be one of these, isn't it? Yep. All right, it would have worked out if we had done a fraction. Add 1 to both sides, cancel. 3x equals 1. Divide by 3, and x is equal to 1/3. That's our third answer, which, by the way, is right here. So if we had gone on to the next fraction, we would have found that that is one of the roots. And so now we have 3 solutions to this polynomial equation. Those answers are 1/3, negative 1, and negative 7. Okay? Let's do one more now. All right, here's another example for you. This is a polynomial equation. 2x cubed plus x squared plus 20x minus 5 is equal to 7x cubed minus 16x squared plus 36x minus 9. I think what you should do is pause the video, spend maybe 7 or 8, 9, could take you 10 minutes to work through this, maybe a little longer, but you have to put this time in. It's the only way you're going to learn it. Watching me do it is not going to help you learn. Putting your pencil to paper and trying yourself, even if you fail, even if you struggle, that is what's going to help you learn. So try this one. Go ahead and pause the video and try it. All right, so let's see what you did. Now, I've got a 2x to the third and I've got a 7x to the third. I want my lead coefficient, my highest power coefficient, to be positive. Therefore, I'm going to cancel this side and bring it over to this side. And it doesn't matter if you move it all over to the right side and the 0 on the left side. That's fine. It's still the same thing. So here, I'm going to subtract 2x cubed here and subtract 2x cubed here. Cancel. I'm going to subtract x squared here, subtract x squared here, cancel. Subtract 20x here, subtract 20x here, cancel. Add 5 here, add 5 here, cancel. This side becomes 0. This 7x cubed minus 2x cubed becomes 5x cubed. Negative 16x squared minus 1x squared, or minus x squared, is minus 17x squared. 36x minus 20x is 16x, and negative 9 plus 5 is negative 4. And so now I have a polynomial equation equal to 0. So I have this expression, and I want to know what the zeros of this expression are. What x's will cause this equation to equal 0? And I can use synthetic division for that with the remainder theorem, the factor theorem. And to get the numbers I'm going to try out, I'll use the rational root theorem with 4 as my p's and 5 as my q's. Okay? So 4, what are all the factors of 4? Whole number factors of 4 are 1, 2, and 4. 1 times 4 is 4. 2 times 2 is 4. Okay? 5. The factors of 5 are just 1 and 5. So that should be easy enough. Now I'm going to put my p's over my q's. So 1 over 1 is 1. So that's positive 1 and negative 1. 2 over 1 is 2. So that's positive 2 and negative 2. 4 over 1 is 4. So that's positive 4 and negative 4. Now I'm going to put these same 3 numbers over 5. 1 over 5 is 1/5. So that's 1/5 and negative 1/5. 2 over 5 is 2/5. So that's 2/5 and negative 2/5. Hopefully I don't have to do the fractions. And then 4 over 5, that's 4/5 and negative 4/5. So you can see here I have 12 possible rational roots. And it's possible that none of them are factors. but it's possible that up to 3 of them can be factors. It's possible that 3 of them are factors. We'll see. All right, now we've identified all the possible rational roots. Now we're going to plug them in one at a time using synthetic division. All right, so first one I'm going to plug in is this 1 here. So I'm going to put in a 1 in the half box. Then I've got a 5, a negative 17, a 16, and a negative 4. I'm going to put a 0 here. 5 plus 0 is 5. 5 times 1 is 5. Minus 17 is negative 12. Negative 12 times 1 is negative 12. Plus 16 is 4. 4 times 1 is 4. 4 minus 4 is 0. Hey, I found my first factor. Awesome. So it's positive 1. So what factor goes with a positive 1? What factor goes with a positive 1? X minus 1, right? So one of my factors is x minus 1. Now this started off as an x to the 3rd power polynomial, right? Which makes this an x to the 2nd power polynomial, right? X to the 2nd power. Let me go ahead and write this out. So I have now 5x squared minus 12x plus 4. What if I were to stop here? Well, now that this is an x squared polynomial, I can find out what will make this equal 0 using the quadratic formula. So instead of continuing with this possible roots, I can stop here and I can use a quadratic formula. That way, even if they're irrational roots, I will still have the correct answers. So actually, once I get it down to a squared polynomial, I don't have to keep doing this process. I can now use one of my solve quadratic equation techniques. I could use extracting square roots maybe. I can use factoring. I can use completing the square. Now I can't use completing the square on this, and I can't use extracting square roots, but I might be able to factor. This might be factored using product sum grouping, so I could try that. You can try that if you want to. And then the 4th technique we learned for solving quadratics is the quadratic formula. So let's try the quadratic formula. I know that x is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Well, a here is 5, b is negative 12, and c is 4. So let's do this. X equals negative b is negative 12, so that's negative 12 plus or minus the square root of b squared. Again, negative 12 is squared. Now notice, I'm always putting these letters, the numbers in here, inside of parentheses so I don't make a mistake. Minus 4 times a is 5, times c is 4. All over 2 times a, which is 5. So now x is going to be equal to negative 12 is positive 12. Plus or minus the square root of negative 12 squared, that's 144, minus 4 times 5, that's 20. 20 times 4, that's 80. Minus 80 over 2 times 5 is 10. So this is going to be 12 plus or minus, what's 144 minus 80? Well, 144 minus 80 is 64. Ah, that's a perfect square. What's the square root of 64? 8. So it's 12 plus or minus 8 divided by 10. So that means one of my answers is x equals 12 plus 8 over 10. And the other answer is x equals 12 minus 8 over 10. Well, 12 plus 8 is 20, divided by 10 is 2. There's 2. 12 minus 8 is 4. 4 divided by 10 is 4 over 10, or this can be reduced to 2 over 5. Which is right here. I'm done. I just skipped over a bunch of steps. I skipped over any additional synthetic division. I skipped over turning it into factored form, and I was able to jump straight to solving for the zeros. And so my answer to this quadratic equation is, my answers are x equals 1, x equals 2, and x equals 2/5. And if you want to, you can go back and instead start at the 5, -12, and 4, and you can plug these in and see if they are indeed, if they give you a remainder of 0. But I want to show you how really what you can do is you can modify this procedure. When you get down to a squared polynomial, you can then just solve for a quadratic equation. That's all I have for you. That's solving polynomial equations. This is what we have built up to. This is what the main thing that you have to be able, one of the two main things that you have to be able to do in this section before this test, and you will have to solve one of these when you take the test, okay? All right, I will see you in class.